Right, this is a promised VPA revision tutorial, virtual population analysis revision tutorial, and I'm just going to run through what you would do, what you should do if you're confronted with the data that look like this. Okay, so here we've got data by year, so we've got 1981, 82 onwards up to 1990, and then we have effort for each year. And we just assume that that's the number of boats. And then we have numbers of fish, or tons of fish, units of fish, let's call it, for each year and an age class given that will have been taken using Otilus. And you can see it makes, well, it should make some sense if you follow the age in this direction. Can I do this? So if I shade all of these yellow, that's one particular year. These fish were all recruited to the fishery in 1981, and these are the numbers of fish caught at each age. Now remember, these are catch figures, so they're not reliable for a whole load of reasons that we've talked about in lots of lectures. And what the aim of VPA is to try and work out what the number of fish actually in the population is, and try and get some estimates of fishing mortality. So the letters you need to remember are F, which is fishing mortality, M, which is natural mortality, Z, which is just mortality, it's total, and N, number of fish, and C, which is catch. I think that's all of it. And what we want to be able to do is to follow through a cohort of fish and try to work out how they've been affected over time. Now, before we start doing any equations or anything like that, the first it's good to do some basics first. So why don't we take a look at total number of fish? So if we put total here, work out how many fish were caught each year. So equals sum, drag that down, shift right, control R, send it right. Okay, so that gives us total number of fish caught in each year. And we can do things like, we can just do a quick plot of nope, that's not good. Let's get rid of that. Don't want that series. That's not a very good example of doing a plot, is it? But anyway, it shows us what's going on here. So here we've got, I haven't put any more details in. Really, we should do this so that it's got years along the bottom, and it's got the number, the fishing effort along the side, and that should all be labelled if you want to get a good mark. If you're not doing one of these. So here we've got numbers of boats, and you can see something fairly dramatic has happened at some point along the way. Oops. It's a bit rubbish. Right. See, I use R. It's much better. Right. So anyway, there's the figure of time against number of boats, and let's just do the same again. We'll do. Oh, it's a 9 program. All right. Right. We'll do year and total number of fish caught, or units, can't remember, whatever they are. And now you can see that there's something similar going on there. So you can see there's something about, so a lot of fish caught in the, what's that, that's 1984, there were an awful lot of fish caught, and that's the first year where there was 100 boats. So there's a story here, isn't there? So that's 1983, okay? And in 1983, which is the third year on here, there weren't 100 boats, there were only 50 boats. So obviously, or maybe not obviously, but to me, I would look at the story and say, right, 1983, there was a sort of gradual growth of numbers of boats fishing. Then 1983, there were 50, and they made a killing. They caught loads and loads and loads of fish, so lots of other boats came to join them in the hope that they would make a killing as well, and they did alright, but they would have caught half as many fish each, remember, that's total catch. And then it all started to go pear-shaped and everything just collapsed. So we could do that. I'll get rid of that now, done those. Make sure if you're doing any graphs and stuff like that, you make them really clear, make it clear what's going on. Let's just do one more figure, just as a sort of a look-see. Let's do effort against total. So what's going on here? We've got effort along the bottom, we've got total number of units fish caught here up the y-axis. To me there's could be something interesting going on there. Fish could be in two states. Possibly there's some sort of funny population thing going on and it's not a stable state population, for example. It's either very low or very high. But again, remember it's all based on catch, and catch is rubbish. Right, so we've had a quick look at the data, we've got a feel for it, we've done a few graphs, and maybe copied them over onto the Word file. Now we want to do is actually do the virtual population analysis. And if you remember, VPA starts with this equation here, which is, it works out how many fish there would have been in a particular year based on what the catch is that year and what mortality was. Okay, so we did the proof for this in class, but I'll not do it just now. Just move it out of the way so I can remember what it is. Right, so that only applies to this year here, to these years here. Right, so let's give that what's the final colour? A grey. Right. Okay, so you only use that equation here because you're kind of having to do some guesswork here. We've got to work out what we think mortality is, fishing mortality, and we've got to work out what we think natural mortality might be. If a fish lives for 100 years, it has a very low rate of natural mortality in the final years. If a fish only lives for 2 years, it has a really, really high rate of natural mortality. This fish lives for 6 years, so my guess would be it's going to have a natural mortality of something around 1/6. Okay, we could. This is a gross approximation, but remember that natural mortality is a gross approximation anyway. Let's give a natural mortality rate for this fish of about 1/6 each year. Okay, so if 1/6 die off each year, then you'd eventually you get to year 6 and there wouldn't be that many of them left. Right, so what we're going to do that. I want to hold on to natural mortality because I might want to be able to play around with it in later on. So I'm going to put natural mortality here. I'm going to make it 0.167. And I'm going to do that all the way down here. And then here, what I'm going to do is I'm going to keep that, just in case I want to play with this. I'm going to make it equal to that cell. I'm going to put a dollar sign in. If you remember, the dollar sign stops the cell reference from moving, so it always says 0.167. So now if I decide I want to change something, like make that 0.2, I can do that for all that year in one go. And if I wanted to change things over time, say I thought the natural mortality was much higher in 86 and 87 for some reason, I could change that as well if I wanted. But let's just do it that way. Right, now we need fishing mortality. One, 2, 3, 4, 5, 6. Now we don't know what that is for any of these yet, but we know we're going to have to take a guess for the final year fishing mortality. So we can assume it's pretty high because the fish are larger. There are lots of reasons why it might not be very high, but that's a fairly standard assumption to make. So we'll assume it's pretty high, and we'll give it a value of 0.6. I think works for me. Oh, that's not going to work. Right. I'll do that for all years at the moment. I can change that later on if I want. Now I want to work out how many fish there were in the final year. So total. No, let's just call it population. Fish population. Now I'm starting to lose track of it here. So what I'm going to do is stick the years in here, so I can see. You want to practice this again and again and again and again and again until you can do it really quickly without having to think too much about it. Although maybe not too much of that, not having to think about it too much, because that's when you start running into problems, isn't it? Right, I'll try and do this in one equation. I have recommended to a few of you that you do this in bits rather than try it and do it in one equation. So I'm going to apply this equation here. So it's the number of fish in year 6, it will be, is equal to the catch in year 6 divided by fishing mortality over total mortality times 1 minus exponential of minus total mortality. Let's see what happens. Right, so we'll start in the far right hand corner. Here I'm going to, so first thing I need is catch, so equals for the thing sign first. Let's get the catch. What was the catch in that year? It was that. Okay, so if I left it at that, it would be 128. Then I want to divide that by, right, I've got a couple of operations to go on here, so I'm going to put a couple of brackets in, at least 2. So my next thing is F3, so that's, well, it's F, it's the fishing mortality that year, divided by total mortality, so that's that, plus that. And I'll close that bracket. So now I've worked out the F over Z component there, and that's going to be multiplied by 1 minus EXP minus, I've got to add these together again. You could have another box, I guess, where you added these together and you had a box for Z. Now, how am I doing there? Ooh, right, so I haven't got enough brackets. It's automatically sorted out though, so let's see what it says. 307. I think that's right. Okay, so that's worked out. We can test that, because if we increase fishing mortality, what happens to that? It goes down. That's okay. 0.6, 0.2. Just mess about really. 0.6. So there's my. So that's now I've done that for 1 year. I can do that for all of them now. I can say that's there you go. So that's that bit done really. Now what I have to do now is work out. This is the number of fish that there were aged 6 in 1990. That must have come from a population of fish that were aged 5 in 1989. Okay, so. Let's just show that nice and clearly. Let's have a, what we're going to put in there. So that's that year there. Those fish there. Now, when I work out the population, there's a check. It should be that as I move back through the population, the number of fish gets larger. It has to, okay, because there's a number of fish in the population. Now if we go back to Pope's approximation, that's the equation that we've just done. The next equation we want to do is this one, okay, which is to work out the number of fish there must have been in the year previous, which is NT plus 1, and then you calculate that by, you've got the number of fish the following year, you multiply that by EXP of natural mortality divided by 2, add the catch to it. That's the way of accounting for catch and natural mortality halfway through the year. Then you've got to do it again for the whole lot for the end of the year. And this is Pope's clever approximation that works out the number of fish in the population based on catch, natural mortality and fishing mortality. And in this you know that the things that you really definitely know are catch. And then the other things we've kind of worked out with it from bit mixture of guesswork and extrapolation. So let's try applying that equation. Here we go. So into this box here we need to put an equation in. So let's just put a bracket there. So it's the number of fish at nt plus 1, which is that number there. And we multiply that by the exponential of natural mortality in that year divided by 2, and then we have to add the catch in that year. Let's say catch in the same year. Yeah, not catch in the following year. Remember that. Okay. So I've done that first bit. Let's see if my brackets are all the same colour. It's good. So I've got 2 greens and then 2 blacks. That looks pretty good. Now I've got to multiply that by the exponential again of natural mortality in that year divided by 2. Right, now if I copy that, you can see it's making some sort of sense because everything is going back up through. It's getting larger as they get younger, which is as it should. Now I can probably copy and paste that one as well. And no. Right. Can I do it all the way along? I can. That looks pretty good, doesn't it? So you can actually just do it all the way up here. Put one in here. Now it's going to come up with a. It's going to tell me there's a mistake here because there's got no reference. Oh no! Why has it done that? Never mind. That's better. So obviously, right. So it's just do a check. Every one of them do this. Tell the same story. So number of fish in the population. There you go. 1, 400, 30,000, 38,000, 48,000. That's as far back as you can go for that. So there's only 1, 2, 3, 4, 5 years here where you can work diagonally and you have all the data. Now the problem years are, the problem years are these ones, aren't they? And it's up to you to come up with a method to, there's no correct answer here. You need to come up with a method that you think is justifiable for these. So these are the problem ones. You could use the end of cohort equation, which is that first one, for these ones, I guess, and then work back from that, or there might be other ways you could do that. Right, so we've got that, but we want to know what fishing mortality is for each year, because that's kind of important to us, and we might be able to tell some more of our story from that. Okay, so how do we work out fishing mortality? Let's go back to Pope's equations. These are all on the sheet that you'll be given in the exam, by the way, so you don't have to remember these. You just really need to know how to apply them. You need to, I mean, it's even better, go through those notes and stuff so you've got the theory in your head, because then it just makes explaining things a lot better when you're not just doing it as a recipe. You should be able to explain, you'll be much more articulate in how you explain stuff. Okay, so let's work out fishing mortality here for, well, we've got a problem here that we can't do it for the same cells that we can't do it for in here. So can I can't remember in Excel if you can copy the colours. So control copy. It just makes life a bit easier if I can see what I'm doing there. Paste. So you paste special. don't think I can. That's a shame. Rubbish program. Bet you can do it in R. Right. Okay, so I'm not going to be able to do the same ones that are grey in here, because when you look at Pope's the method for working out what fishing mortality is, you need to have a number of fish around in 1 year and the following year. Okay, so let's just move that back. But I can do this one. Okay, so it equals, I think it's ln, yes, natural logarithm of number times number of fish at time t divided by the number of fish at time t plus 1. Now that, if I just press return on that, oops, why is it not doing that? Oh, my incompetence, right. So that is total mortality. What we need to now, you see that's quite high, so that's quite scary. That's well above 0.6. Now, one of the things that would make me think is actually, well, if it's 0.6 at age 5, I wouldn't expect it to be any lower at age 6. So I might then go and change that. And you can do that in this, using this method rather than the iterative method which we did the first time around, because everything will change properly. So we can subtract natural mortality in that year from there as well. So we'll subtract that 0.167, and there we have the figure for fishing mortality in that year. Now you could have another box with total mortality if you wanted, I guess. All right, let's just copy this. Copy. You see, I haven't done it right to the end. I don't think it would make sense right at the end, because it would be, where would it? Well, we can do it. Let's see, where's that referring to? So I click on here, it tells me what it's referring to. Oh no, it's okay. Oh yeah, it's using the year before. Right, fine. Okay. Let's see what it does when I do this. Right, so you can see where the problems are starting to arise with this, so we can't get these figures of fishing mortality in these boxes here without doing this, whatever we decide to do that's clever. There. Okay. So now we've worked it out. That's only half the thing though. Now note, that's taken me 22 minutes to do. 22 minutes and 55 seconds. And all I've done is do the maths. You've got to do that, and then you've got to answer the question as well. So it's, you know, there's a bit of work to do there, and you've got to do the graphs and copy them over. So you've got to be able to do this properly. Okay, I think I'll leave it there, and I urge you to do as much practice as you can, and play around with it a bit. You know, play around with what happens if you change natural mortality. There's lots of questions that you can ask of the question using this method. Okay, but most of all, good luck.